But let's run through it. Got it? Oh, you're sitting up there. All right. What questions would you have for me, being I didn't put any of them up on the video? I'm sorry. Yeah.
Can you do number 15?
15, backside, huh? Ooh, baby. All right, number 15. Let's see. I'm going to do this. I'm going to get rid of that. I want to capture this. Copy file. Paste. Okay, way too big of a graph, but we'll reduce that down. All right, there we go. And I'm sorry, 15? Okay. Number 15 says we have they have k at x. I'm just going to call it y. Is that okay? K at x means the same thing. So we have negative 1/2 x plus 5 x minus 3. This is a good one to ask about. Thank you. So, friends, does anyone see quickly that negative 1/2 out front is not going to change where it crosses the x-axis? Does that make sense? So can anyone tell me where this would cross the x-axis? Yeah, so I'd get negative 5, 0. Now, does there anyone not realize why that happens? So basically, I'm just going x plus 5 equals 0, and then subtracting 5 from both sides. That's how I got that. So negative 5, 0, so 1, 2, 3, 4, 5. I got a dot here. And then where's this one going to cross 0? 3, 3, 0, right? That's supposed to be a 3, I believe. 3, 0. Everyone okay with that? So now we have to kind of think about what's halfway in between those. Well, the distance between them, the red dot from the y-axis is 5 away, because remember, distance is always positive. And the blue dot is 3 away. So if I add 5 and 3 together, I get 8. If I divide 8 by 2, I get 4. So if I count 4 back on the blue, 1, 2, 3, 4, I get to there. If I count to the right from the 1, 2, 3, 4, I get to the same location, which is great. So I'm just going to kind of put my axis symmetry in there. All right, so that's my axis symmetry. So friends, we've said this many times. What's definitely going to live on that axis of symmetry? The vertex. Okay, so I know that my vertex is going to be at negative 1 comma something. Agree? All right. What should I do to get my y value out? Yes, very good. So I'm going to take this value here, and I'm going to plug it into both of the x's. But I have the whole equation. I have negative 1/2 times negative 1 plus 5, and then negative 1 minus 3. Okay, this is where my x's used to live. Agree? So let's do some math. Negative 1/2, let's not worry about that yet. Negative 1 plus 5 is the same thing as 5 minus 1, which is 4. And then negative 1 and negative 3 combine together to give me negative 4. Okay? So I have a negative times a positive times a negative. So my answer is going to be positive, right? Because negative times negative. 4 times 4 is 16. What's half of 16? 8. All right, so I get a vertex at negative 1, positive 8. 3, 4, 5, 6, 7, 8. Does it make sense that this parabola is opening upside down? Yeah, what's making it open upside down? The negative on the 1/2. Agree? So what happens when you have a fraction, and a fraction being between 0 and 1, so like 1/2, 1/3, 1/5, 1/8, 1/10, that makes your parabola fatter and fatter and fatter. Okay? The larger the number, so if you had like 3 or 4 or 5 or 6 or 7 or 8 or 9 out in front, and it's not a fraction, that means Earth probably becomes skinnier. It has to do with something called a vertical stretch, which is numbers bigger than 1, versus a vertical compression, which is, and you don't have to know those terms. It's just that will come later in math. Any other questions you want to take a look at? Yeah, you got it. And I know we didn't have to do it, but that's okay if we see it, okay?
Yeah.
Paste. Oh, shoot, I meant to. Remind me as soon as I reduce this down to copy it. No, I'm just going to keep making gigantic graphs. What are you supposed to remind me to do? Copy it. Okay. Copy. That way it comes back. So number 16, no, it wasn't assigned, but it's fine to take a look at it. So they have y equals 1/2 x plus 4, x minus 6. Okay? So where is this going to cross the x-axis? -4. So -4 comma 0. You good with that? So 1, 2, 3, -4. All right, where is this one going to cross the x-axis? 6. 1, 2, 3, 4, 5, 6. So basically the distance between those 2 points, the purple dot is 6 away from the y-axis. The green dot is 4 away from the y-axis. So 4 and 6 add together to give me 10. 10 divided by 2 would be 5. So if I go 5 in, 1, 2, 3, 4, 5, I get to here. If I go 5 this way, 1, 2, 3, 4, 5, I get to the same location, which is good. If you don't get the same location, you made a mistake. So that red dot is going to refer to where the axis of symmetry lives. So axis of symmetry lives right down this lane. What lives on that axis of symmetry? Vertex, very good. So my vertex looks like it's going to be at 1 comma something. So friends, how am I going to get that something? Yeah, I'm going to plug 1 in there, 1 in there. So I have 1/2. 1 plus 4 is 5. 1 minus 6 is -5. And I would never put one like this on the test because this is going to come out to a decimal. 5 times 5 is 25, right? And half of 25 is like 12.5. Half of 25 is 12.5. Or negative 12.5. All right, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.5 is like down here. I got plenty to draw my parabola in, and la-ti-da. It's supposed to be straight, but you know, it's got tremors. Anything else I could help you with? Yeah.
Number 11.
Number 11. Okay, so in the situation on number 11, what you're looking at, that's a good one to ask about. Number 11, you had h at x, which is the same thing as y, and you can always change the functional notation to y if it makes it easier for you. So both of these are the same. Agreed? So this means that I know that I'm going to definitely have -3 comma 0. They both gave me the same answer. So this also means we have a vertex that's at that same location. Okay? So -3, 1, 2, 3. That point right there is my vertex. Okay, because they're the same. My axis of symmetry goes right through it. That's my vertex. But then you're like, well, how do I graph the rest of it? Well, this negative means it's going to go down. If I had multiplied this out, I would have gotten x squared. So my pattern graph is going to be a times 135. And just note this, if I multiply those together, I get x squared. Agreed? If I have that negative, it's negative x squared. So it's going to be -1, 135. So just using a little logic on it. So -1, -3, -5. So I'm going to go right one, down one. left one down 1, right one down 3, 1, 2, 3, left one down 3. So that's what that parabola should look like, which would be downward open. Looks like letter G is the graph that you would go with. Okay. Anything else? Happy? Content? Yeah. 13. 13. Let's see. Paste. Number 13 says this. So we have y equals x minus 1 and x minus 7. So what point will this one give me? 1, comma 0? Is that okay? Which is right there. What point will this one give me? Yeah, 7, comma 0. 1, 2, 3, 4. Right. 1, 2, 3, 4, 5, 6, 7. All right. So the distance between those points would be 6. You okay with me saying that? If I counted it up, I could just easily just count saying 1, 2, 3, 4, 5, 6. Halfway between the number 6 cut in half. Hey!
Hey, how you doing?
Doing well.
Do you have Jordan home?
I do.
Oh,
I do.
he just needs to go see Dean Devitt. Or is it?
Right now?
No, after on next period.
Oh, okay.
Where?
Yeah. You need Jordan, Oliver, Dean Devitt after what period?
This one.
After this
Go see
period.
after this period, okay?
Cool.
Thank you very much.
Yep. You know what? He might have gotten a coupon late in the period, and it might have sat here. I think I remember that yesterday. So if that happens, I think you got a coupon yesterday. I didn't give you one, I don't think, after this period. So if she's like, hey, it's not something for it was my fault. I forgot to give it to you. Okay. So let me know if she needs me to email her. You can say no email stirrup, I swear, and I got you back. Cool. See ya. All right. So we decided their distance was 6 apart. So that means 6 divided by 2 is 3. So from the green dot, go left 3. From the blue dot, go right 3. And you should wind up about there. So there's my axis of symmetry. So that is 1, 2, 3, 4. That's 4 in that direction. So I know my vertex is going to be at 4 comma something. What should I do to get the value? Plug it in. So I'm going to get 4 minus 1 and 4 minus 3, or 4 minus 7, excuse me. So that's 3. 4 minus, that's negative 9. Or that's, sorry, that's negative 3. If I multiply them together, I get negative 9. So 4, negative 9. 1, 2, 3, 4, 6, 7, 8, 9. There is plenty of data to graph that now. We good? Yeah.
Can you do number 19?
19. Yeah, so they gave us x equals negative 1 and 8, which means you have x equals negative 1 and you have x equals 8. Still with me? Now you're going to kind of reverse engineer it. You want it equal to 0. So you're going to add 1 to both sides. So this gives me x plus 1. This gives me x minus 8. Okay. So my parabola in factored form looks like this. If they wanted us to put it in standard form, SF, you'd multiply this out. So x times x, you get x squared minus 8x plus 1x minus 8. Combine those like terms. So I get x squared minus 7x minus 8. So this makes the same parabola as this. It's just one's in standard form, which is like what we did with the negative b over 2a, the pattern graph, 0 comma c, and all that kind of stuff. But it makes the same picture. Good? Yeah. Yeah. 17, x equals 0 and 5. Okay. X equals 0 means I'm just going to have x. Okay? because I can't, if I go x plus 0 or x minus 0, it's still x. This one's going to give me x minus 5. So this is my parabola in factored form. If I multiplied it out, distribute, I get x squared minus 5x. Okay? Seem good? All right. Friends, we are eventually going to be on page 105. All right, so go to page 105. Now, before we do anything, I just want you to watch to see if we can discover what kind of is taking place here. So I'm going to use a graphing tool called Desmos. Okay, Desmos, you're more than welcome to put it on your phone. It's a free app. It's a free graphing calculator. It's a lot better than the graph calculator. No, I'm not going to have you use it. I just want you to know that Desmos is available. So I'm going to do a couple of graphs. So y equals x squared. Okay, and let me just take that to the home. Okay, parabola. Agree? Okay, now watch this. Let's have a second parabola. This one will be in blue. Y equals x squared plus 3. Uh-oh. So take a look at the two graphs. One's red. First one we graphed is red. The second one's blue. What do you kind of notice about the two graphs? What could you tell me? What's the difference from the red to the blue, just the most obvious? It moved up. How many do you think it moved up?
3.
3. Yeah. Okay. So if I did something like this, if I did y equals x squared, x squared minus 5. So what do you notice? The red is our original. What do you notice about the green one, the most obvious? Some people might say, well, it's wider. Well, it is wider, but what do you notice about the vertex? It's moved down. And would you feel comfortable if I said it moved down 5? And the nice thing with Desmos is you could hover over things. So we could say I got that point, and this point. All those points are my vertex. Agree? So notice how when I added or subtracted just from an x squared, it did a little different. Okay? So I'm going to clear these out. Okay? I'm going to keep my original parent function. Bless you. We're already on the thing. Okay. Now I'm going to make this look a little different. Not anything bad. Okay, so it's still a parabola, agreed? But what do you notice about the parabola? Did it move up or down? To the side. Which direction did it move? Left. Now take a look at the equation. It says x plus 3, but it moved left. So I think what that would mean is, let's see if we can discover this. If I want y equals x minus 3, quantity squared. Okay, so one of the weird things that takes place anytime you group something in math. Group means I put it in parentheses or square brackets. Are you with me on that? If you group it, it's going to shift it right and left. And it doesn't matter if you're doing parabolas or really weird looking graphs. If you have a grouped value, it will shift it right or left. Okay? But it shifts it the opposite direction that you would think. Now, before, remember I had the one like this. Let's do, I can't remember the exact equation. Y equals x squared plus 3. So that just moved it up, right? So the plus 3, it makes sense that it moved it up, or I want minus 3, it moved it down. But then we get into this whole parentheses debacle, and it's shifting it the opposite direction. Huh. So let's think about, yeah.
So is it like doing that zero thing that we did?
That's exactly it. So when we were doing when we had like x plus 5 equals 0, and then you go subtract 5 from both sides, and you get x equals -5, or if you work backwards, that's why it becomes opposite. That's the exact thing. That's huge. That's huge to see it. So kind of with this information, I want to talk about our notes. Now, friends, you got to trust me. Hey.
Did you see Emmanuel real quick?
Emmanuel? Yeah. Whatever he did, he's fine.
Not in trouble.
Okay.
Sorry to interrupt.
You're perfect. All right. So these ones we already did. So this went up 3. This went down 3. Or down 2. Okay? But those aren't grouped. They're not in parentheses. Agree? So that's the first thing. And this one, when you just have x squared, it's something that they call the parent function. It's the most basic parabola you would get. You have a vertex at 0, 0. Your pattern graph works as 1, 3, 5. Your axis symmetry is x equals 0. So there's all kinds of things like that. So if I add something and it's not in parentheses, it's going to shift the graph up. If I subtract something and it's not in parentheses, it's going to shift it down. Okay? So again, this is our parent function. So this is going to go left 3, and you always use your vertex as your thing, and this one will go right 2. Okay, and I'll graph them in a little bit, but I just wanted to get us kind of in a spell. Okay, so let's do this. We don't even have to write this down. We just watch. Okay. What is this known as? Parent function. Okay, we good? And things that you should know about the parent function is just 0, 0 is where your vertex takes place. Okay? Knowing what you know right now, where is my vertex? What? Is it in parentheses? 0,7. So this did a shift up of 7. Does that make sense? Here, let's try another one. Same idea. How much did this shift up? So it shifts up 10. So what's my vertex should it be? 0, 10. Okay. What if I had this? Yeah, so shift down 3. So what's my vertex? 0, -3. See a pattern there? So none of these are in parentheses. Okay? So none of these are in parentheses. So it's just moving the graph up and down. That's all it's doing. Okay? So again, what is this one known as? Parent function. And the vertex of a parent function is where? 0, 0. Okay, so let's do it the origin. All right. is that in parentheses? So this one's not going to shift up or down because I'm not adding anything to it. Which direction is this going to shift? Left. Awesome. Shift left 5. Okay? So my vertex to this is going to be -5, 0. So notice when I was adding or subtracting, that wasn't in parentheses. I was changing the y value of the vertex. If it's grouped, you're going to change the x value. So what about this one? Which way is the shift? So shift left. How many? 8. So what's my vertex got to be here? -8, 0. Okay. Let's change color. Oops. What do you think? So it's going to, oh shoot, shift, right, sorry about that. What's my vertex? 4, 0. What's this one going to do? So it's going to go right, shift right. I'll try and remember the F this time. So what's my vertex? 6, 0. Okay. All right. Last thing to talk about. Last thing to talk about. All right, actually 2 more things. So what is this known as? The parent function, okay. And what's the vertex of the parent function? 0, 0. Okay. Ready to have a little horsepower? What's going to happen here? Okay, I'm going to say left how many? Left 2. Anything else? It's going to go up. Up 5. Right? Because the grouped part is moving it left, right. The non-grouped part is going to shift it, if it's positive, up or down. So let's see if we can figure this out. What is my vertex? Close. Stay with the 2 though. -2 and no 5. Okay, so think about this. If I'm going left from 0, I get to -2. If I'm going up from 5, I get to 5. See that? What about if I had this? What do you think? Left 6, good. Down 3. Close. -3, because it went down 3. Ooh, baby. So if you know your vertex, you have a good starting point on a graph. Okay. So, and I know this isn't really on the notes. What do you think would happen here?
Oh, I know. If this was homework, I would just close my notebook and place it.
Do what? Don't worry about MX plus B yet. Let's ignore the 3 right now. Close. It's going to go right 8. Right 8. Good. Right 8. Up 2. So that means that my vertex is at 8, 2. Okay? So let's talk about this. 8, 2. There's my vertex. All right. Now you remember we had this here, right? So this is my A value. And we use the A value to pattern graph. A times 135, right? So this is going to be 3 times 135, which is going to be 3, 9, 15. So I'm going to go right one up 3, left one up 3. There's my parabola. Okay? So, my friends, I am not going to bury you in any shape or form. But I would like you, for tomorrow, to do page 107, do problems 1 through 6. Got it so far? Friends, listen. Shh, 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 shh. We have a quiz tomorrow. There are 4 problems. You still with me? What I will do, listen. So, I will tomorrow have a note card handed out to each of you. Shh. There's 4 problems. On the note card I hand out to you, we will have one problem, which is a parabola like this, 2x squared plus 4x plus 6. You'll have a parabola like that. That's old one. We'll work it out. We'll work one out. We'll have a parabola that might look like this. And then we will have the 3rd and 4th parabolas that will look like this. But on the note card, what I'll do is I'll work out 4 similar problems. You will then write those 4 similar problems on your note card. I will then say, okay, here comes your 4-question quiz, and you can use your note card on it. Is that okay? You trust me? I'm not going to bury you. You guys just walked through a pretty tough concept, and you verbally told me how to do it. And you even got to see that I put the bad word because I forgot to put the F in with shift.
I didn't know your name was there. I was like, you know that one kid? That one guy who comes in?